topics, and I think it is very much interesting for everyone in computer science, and enjoy the session. Thank you. Terima kasih.
Okay, thank you so much, Miss Dr. Arif, for welcoming speech. So let's continue to this event. The first, we have a special topic: AI and natural language processing implementation in industry. So the first speaker from Universitas Amikom Yogyakarta, Director of Postgraduate Degree at the Amikom University, with the topic Artificial Intelligence Concept and Implementation. So please welcome Professor Dr. Kusrini M.Com.
Thank you very much, Marotta, yes, for the time. And hello, everyone. Thank you for joining this webinar. It's really a honor for me to stay here and share my little experience related to artificial intelligence to a lot of you. And actually, the main speaker today will be Simon. Simon, hello. Are you there? I think he has joined this meeting. Yeah. Uh, Actually, Simon is not from Spain, Marotta, but from Italy. Yeah, from Expert AI from Italy. Yeah. Thank you very much for your willing to share your experience in NLP in this webinar. The main audience in this webinar, I see in the list is very variative. Yeah, sangat banyak sekali macamnya. There is a student from University Amikom, yeah, Amikom Universitas Amikom Jogja, and then I see there are many friends from other university as well, even from high school. Ya, mungkin ini gurunya or muridnya, I don't know, but yes, it's really appreciated to it because all of you give your time to discuss with us in this session. Actually, maybe I don't want to give materi kuliah, no, yeah, but just sharing. Maybe you can use the time in question and answer to discuss more. And I put my speech before Simon because I want to show you the concept of artificial intelligence, and then also before Simon will demonstrate the implementation of the artificial intelligence in his company in Expert AI, and also I want to emphasize why we have to learning artificial intelligence, how importance of artificial intelligence. Okay, let me share my screen. Okay.
Hey, Kusrini, sorry.
Oh,
Can you
yeah.
can you hear me?
Yes, yes.
Okay, just testing. Sorry. Go on.
Thank you very much for joining. Yeah.
Thank you for inviting me. Thank you.
Okay, great. Then, I put three pictures in this slide. In the first slide, the first one is me myself that edited by Mbak Putri. I like very much with this pictures I put here. It's just like AI banget gitu ya. And then I looks like prettier here. So I love this picture. Thank you Mbak Putri and team. And yeah, the second picture is again my picture again. Ya ini kayak narsis banget ya teman-teman ya. This is my picture when I went to the Ford Fest in Borneo, taking some picture ya, gambar dari menggunakan drone. Actually, it's just acting ya. I can operate this one. Pak Mimboro, the students of MTI ya, Master Informatics di Amikom ya, that use this drone, but ya untuk keren-keren ya, saya ambil juga fotonya ketika mengoperasikan ini. And the third one is lovely picture for me. Yeah, this picture was taken in 19 2019 ya, 2019 in the Queen Mary University of London. This picture. What is the specialty? Why I like this picture so much? Because there is words in the sport. Meet new friends. Yeah, meet new friends. This is very apa ya, kalimat yang sederhana but really interesting for me, because indeed by learning artificial intelligence, by doing research in artificial intelligence, then I meet very much very many people, new people, many friends, yeah, and not only in Indonesia but around the world, including Simon today become our friend. Thank you for yes, willing to be our friend here. And then I want to show you the next picture. This one is taken in this March when I was in Slovakia following General Assembly of Silvanus Project. This is me here, and this is Pak Arif, ya, Pak Arif yang sudah memberikan apa sambutan tadi, and this one is Simon, ya. We are in a team, ya, dalam sebuah tim in the huge consortium, international consortium, ya. Ini sangat membanggakan bagi saya, ya. For me it's really an honor to be part of the youth international consortium, and we are together with 49 institutions from 18 countries, ya. Ada yang dari Italy, including Simon and many others partners, and then from Spain, Portuguese, Slovakia, Croatia, Luxembourg, France, German, ya, Greece, Romania, Czechia, Croatia, Cyprus, ya, Poland, Sweden, and even from Australia and Brasilia, ya. So this is the huge consortium. Kita punya konsorsium yang sangat besar dengan banyak sekali apa namanya teman-teman di situ, begitu ya. And yes, here because of artificial intelligence, then ya, saya Pak Arif bisa bergabung di sini, ya. Itulah kenapa we have to learn artificial intelligence, because there are many opportunity behind that. Okay, yes, this one, and we get funding, ya, Silvanus. We get funding from European Union Horizon for research projects along 4 years from 2021 until 2025. The project cost is about 24 million euro, and the funding we got about 19 million euro, ya. Kalau di Indonesia kan dirupiahkan ini sekitar 300 miliar, teman-teman. Yes, there are many academic partner, industrial partner, yeah, SMA organization, and etc. And Amikom here. Amikom become one of the international partner beside Shiro. This is from Australia, and then UFRG. This is from Brasilia. Yeah, there are 3 international partner, including Amikom here, and yes, I'm become the PIC from Indonesia and fully supported by Pak Arif, Puninda, yeah. Pak Arif is like me from informatics, but Puninda come from disaster management model. Urban planning, ya, kalau di Indonesia itu apa? Perencanaan wilayah kota, ya, program studinya itu. And then also Bu Ika Avianita from geography, yeah. So this project is including many partners from banyak bidang ilmu, ya, not only informatics but also from forestry, yeah, and biological and etc. Yeah, so of course to doing this research, not only 4 orang ini mungkin tidak akan cukup, ya, for fulfill the requirement of the European Union. So in each semester we will invite new team member, ya. Setiap semester kami akan mengundang member baru yang akan join di dalam project ini. And this semester we have support from Pak Adit Wilaksito from computer science faculty, and then we have Bu Risa from architecture, we have also Bu Reni from urban planning, and we have Pak Mimboro. Pak Mimboro, are you here? Say hello, Pak Mimboro. Yes, maybe still there is some technical problem. Pak Mimura is informatics engineering magister students, and in the next month we will open next few months maybe we will open recruitment again, including for student from undergraduate. Yeah, this is the overall work. The project is related with artificial intelligence. The title of the project is Integrated Technological and Information Platform for Wildfire Management. Ya, kami akan membangun teknologi begitu yang berhubungan bagaimana cara pengelolaan kebakaran hutan. Ya, and this project is divided into 10 work package, and Amikom become one of the work package leader. Ya, Amikom di sini menjadi ketua di sini di work package 6. Ya, ini Amikom to develop enhanced resilience program for forest management through restoration and adaptation. Ya, bagaimana kita membuat program untuk resiliensi. Ya, resiliensi itu ketahanan hutan. Bagaimana caranya ketika terjadi fire, ya, ketika terjadi kebakaran di dalam hutan, then the condition will be back to the normal. Ya, bagaimana kondisi tanahnya bisa balik, bagaimana hutannya bisa balik lagi, begitu. Dan itu akan kita lakukan dengan menggunakan pendekatan some of artificial intelligence as well. Ya, Amikom also become partners in other work package. Ya, walaupun kita utamanya itu menjadi ketua di sini with many other partners dengan timnya dari banyak negara juga, ya, yang di bawah kita ini. Kemudian Amikom also become partners in other work package to support many work, ya, including prevention, preparedness, ya, detection, respon, ya, restorasi, adaptasi dan sebagainya. Ini ada bagaimana kita membuat AR, VR untuk membuat training, bagaimana kita bisa melakukan pendeteksian terjadinya kebakaran hutan, ya, berdasarkan gambar mungkin satelit atau mungkin dari suhu ataupun dari yang lain, ya. Kemudian ketika terjadi kebakaran hutan, then we have to predict, ya, seberapa besar kebakaran hutannya, akan mengarah kemana. Dan what should we do dengan masyarakat yang ada di sekitar? Apa yang harus dilakukan, begitu kan, untuk menyelamatkan dan sebagainya. Itu dilakukan banyak teknologi yang dikembangkan, termasuk robot, ya, yang nanti akan bekerja sama dengan other partners. Ya, doing this research bring me, ya, maybe not only me but Amikom members visiting many countries, ya. Kita punya kesempatan untuk melihat banyak negara, ya. This is when I visit Slovakia last March. Ya, ini adalah kita sedang mengunjungi kastel di Zvolen, ya, bersama-sama dengan tim, ya, bagaimana kita bisa mendapatkan teman baru. We got many new friends there, ya, including Simon here. This is Simon, this is me, ya. Pak Arif nggak ada di sini because he took the picture, ya. Pak Arif sedang mengambil gambarnya, jadi nggak kelihatan di sini, ya. And then beside, ya, di samping kita mengunjungi banyak negara, kita juga datang ke lokasi because one of the pilot of this project is Indonesia, ya. Indonesia menjadi pilot di antara 11 negara. Jadi pilotnya itu dari 49 institusi, 18 negara tadi dipilih 11 countries to become a pilot, and Indonesia become one of them in the phase C about restoration, ya. And because of that, we have to looking for the policy and then what apa yang sudah pemerintah lakukan, ya, what have done by the government, how to solve the problem of the forest fire and etc. Ini kami datang ke Badan Nasional Penanggulangan Bencana, Badan Penanggulangan Bencana Daerah, BPBD. Nah, ini suka kebalik, ya. Saya sukanya bilangnya basis data, ya, PBD, BPD dan sebagainya, ini susah, ya. And then we also come to police kantor polisi, ya, and then pemadam kebakaran, kantor bupati, etc. Ya, ada mungkin nanti kita akan datang lagi untuk tahu tentang Manggala Agni dan sebagainya. And then we also visit the forest, ya, visit the forest in Borneo in April. We visited there. Yes. Melihat gambar ini, ya, this one we took this picture actually looks like happy picture, ya, wajahnya wajah bahagia. Actually we have problem in this situation because our car is have a problem, stuck in the mud, ya. masuk ke dalam lumpur tidak bisa keluar lagi gitu ya. Dan ini luar biasa. And then we call a friend ya, and then waiting for another car to pull the car because yes, it cannot be done by us. And then yeah, we just trying to enjoy everything there. Ya, kita ambil foto, kemudian mengamati sekitar dan sekitarnya dan lain sebagainya. And then we also have opportunity to visit ya bagian dalam dari hutan. Ini nggak bisa mobilnya masuk ke sini ya, mungkin ada yang perlu jalan, and then maybe we have to use motor trail, yang motorcycle ya, yang khusus nggak bisa pakai motor beat gitu, nggak bisa ya pakai motor trail. And then someplace we have to use kano ya, atau kalau ini orang lokal bilangnya klotok gitu ya. Ini adalah salah satu pengalaman kita ya, bagaimana when we learn artificial intelligence and then doing the research, then we have many opportunities to do many things ya, to help people, government, and etc. And we also met some local children ya, we discuss with them tentang banyak hal, tentang bagaimana sekolah mereka, bagaimana kehidupan mereka, dan selanjutnya. And then we met also many animals ya, including monkey ya. Di sana banyak sekali monyet dan mereka tidak takut pada kita. Ini nangkringnya di mobil saya ya. Ini my car. Yes. Yeah. This is one of my experience by doing research in artificial intelligence. Then I have many opportunity, and hopefully you can have other opportunity, maybe more than what I did. Then back to our main topics about artificial intelligence. Maybe I will actually there are many definitions of artificial intelligence ya. Definisi dari sistem kecerdasan buatan itu banyak sekali, but maybe I just took one ya. Saya ambil satu yang diambil dari New Oxford American Dictionary. Apa sih sebenarnya kecerdasan buatan itu ya? In this dictionary it's defined by the theory and development of computer system able to perform tasks that normally require human intelligence. Ya, bagaimana komputer itu bisa melakukan pekerjaan yang biasanya hanya bisa dilakukan oleh orang-orang yang pintar. Orang yang pintar itu apa? Apa yang bisa dilakukan oleh orang pintar? Minum tol angin? Bukan ya, bukan itu ya. Okay, maybe one of you want to share what things that can be done by intelligence human. Apa yang bisa dilakukan oleh orang pintar? Yang membutuhkan kepintaran seseorang, ya. Kalau melakukannya, orangnya kalau nggak pintar tuh nggak bisa. Kira-kira apa? Oke, termasuk presentasi begini butuh orang pintar nggak sih? Butuh ya. Kalau nggak punya ilmunya nggak bisa cerita ya. Oke, dan mengenali ini Bu Gusrini, ini Pak Arif, ini Mbak Rona, itu tentu juga butuh ilmu ya. Itu yang bisa melakukan adalah manusia. Itu salah satu kehebatan kita. When we meet someone, ya, walaupun mungkin pada saat dulu ketemu itu wajahnya ganteng, bersih, begitu ya. Begitu ketemu lagi sudah berewokan begitu. Then we still recognize them, ya. Berarti untuk melakukan itu butuh kecerdasan. Kecerdasan ini kemudian juga bisa salah satunya kita pengen komputer bisa melakukannya. Kalau kita pengen komputer bisa melakukan seperti yang kita lakukan, then komputer has to program gitu ya, diprogram untuk menjadi cerdas ya, bisa visual perception tadi ya, untuk melihat, mengenali ya, speech recognition, saya bisa tahu ini siapa yang sedang bicara, suaranya siapa ini ya, decision making, bagaimana kita membuat keputusan, and then translation between language ya, bagaimana kita bisa menerjemahkan satu bahasa dengan yang lainnya. I can speak in Indonesian, in English, in bahasa Jawa for example ya, karena apa? Karena kita punya ilmunya ya, sehingga bisa melakukan itu. Dan kecerdasan buatan intinya adalah bagaimana saya pingin that computer can do what I did ya, apa yang bisa saya lakukan itu komputer juga bisa melakukan. Oke, dan apa saja bidangnya dari kecerdasan buatan ya? I took from this one ya, sebenarnya mungkin tidak lengkap-lengkap banget ini pengkategoriannya, tapi mungkin bisa ya bolehlah begitu ya. Artificial intelligence can be divided by machine learning, and then we have natural language processing. Saya Simon will sebutnya machine learning ini. Apa tuh yang dimaksud dengan machine learning ya? Machine learning is an artificial intelligence technology that provides system with ability to learn about being explicitly program. Ya, kita tidak mendefinisikan secara eksplisit, tapi komputernya bisa belajar, bisa mengenali ya. Dengan cara apa? Dikasih contoh kasus ya. For example, when I still young, maybe in still masih anak-anak gitu ya, still children, and then my parents want to teach me about how to classify banana and then mango and then maybe apple and etc. ya. Caranya bagaimana? Mereka secara berulang-ulang menceritakan. They tell me this is banana, this is apple. Mungkin tidak secara eksplisit begitu, tapi bisa bilang, Nduk, tolong ambilkan apel itu yang di atas meja. Then I will recognize things above the table, on the table is apel ya. Nah, ini adalah caranya orang tua kita ngajarin kita ya. Cara yang sama ini diinginkan masuk ke dalam sistem. We will make computer learns by giving some example ya. Nanti di dalam konsep machine learning we will have data set ya, kita akan punya data set begitu, that will divide, ada beberapa variabel, gampangannya kita buat tabel begini, dari variabel 1, variabel 2, variabel 3 and then goal variable ya. Apa variabel tujuannya? For example, I want to identify which is someone is good person or not, a bad person. Misalnya saya mau ngasih pinjaman uang gitu ya. Ini kira-kira orangnya akan mengembalikan atau tidak ya. Manusia itu bisa belajar ya. Ketika S3 perempuan, anaknya 3 like me ya, female ya, and then have 3 children and etc. Biasanya nggak ngembaliin ya. He will not return the payment, for example ya. Then I will put that data into this data set ya. Satu baris data itu saya masukkan di dalam tabel ini. Saya akan punya data banyak. Saya punya misalnya I work for bank, for example, then I have many customers data, and from them we know that there are good customer, bad customer, and then the goal variable will be good or bad, and then I will divide the data set into 2 part ya. Saya akan membagi datasetnya menjadi 2, the data training and data testing. Data training ini itu apa? The function of data training is building the model ya. Bagaimana kita membuat modelnya ya. Kemudian saya akan punya data testing, gunanya apa? Actually I have the result of the goal variable. Saya tahu dalam data testing itu hasilnya dia baik atau buruk, tapi saya akan menguji. Using this data, I will compare the result of the classification ketika saya terapkan model yang digunakan dalam data training, lalu hasilnya gimana? I will compare and looking for the accuracy, ya, and then precision, recall, and etc. using data testing. Then if I got the model, ya, saya sudah dapat modelnya, then what it for, gitu kan? Kalau saya sudah punya modelnya dan dari hasil testingnya, the accuracy is very high, misalnya 99%, saya bisa mengetahui someone is good or bad by the model that developed in the data training, and then I can use the model to other person, ya. Saya bisa menerapkan model itu untuk orang yang saya belum tahu hasilnya, ya. Berdasarkan data testingnya tadi ternyata hasilnya bagus, akurasinya tinggi. Then I will use that model to identify a new person. Saya ketemu orang baru, dia mau minjem, saya akan gunakan model ini. Orang dengan karakteristik dia bagus nggak ya? Akan mengembalikan nggak ya? This is the concept of machine learning. We will give data to system to learn, and then we will test to verify which is the model is good or not, and then if it's good, then we will use the model to identify the new data. Ya, datanya sendiri come from various bentuknya bisa macam-macam ya. This one, for example, this is from my research ya. Ketika saya meneliti tentang mango pest identification, I want to identify which is this image, apakah daun yang normal or maybe it has been attacked by some pest ya. this is the characteristic, gambar-gambarnya kayak gini. Then this image actually come from expert. Yeah, I cooperate with expert from Gadjah Mada University. He has many pictures and it has been classified to the tipe dari hamanya itu ya, Apoderus javanicus, gambarnya kayak gini. Not only one, they have many hundreds or thousands ya. Kemudian is Narcis rostris ya, and then all of this data will put in the dataset ya. Gambar-gambar ini nanti dimasukkan ke dalam dataset, kita train menjadi suatu model, and then we hope that when we meet the new data ya, gambar yang baru, then we can identify which is Cisaperotus or Tagal or Dapula or extra ya. Then another similar case is for face identification. Ini juga penelitian mahasiswa saya, mahasiswa S2 ya. She want to identify is the person is the right person to join in one session ya, sesi kerja ya. Apakah masuk shift itu atau tidak begitu. Dan she used kamera webcam and then identify siapakah orang ini, dia masuk shift ini atau bukan. Kalau dia masuk shift ini kemudian masuk presensi, kalau enggak masuk shift itu, then maybe there's an alert, kamu salah jadwal gitu ya. You're in wrong shift, for example. Ya, ini mengidentifikasi itu. Ya, data tidak selalu berupa gambar. It can be number. For example, this is historical product sales data, and then the others kind of data can be text yang bisa diambil dari berita. Ya, we can take from news, and then from Twitter, for example, Facebook, and etc. So many resources. Yeah, we can also take data. For example, you prepare komentar ketika teman-teman punya e-commerce application, ya, punya komentar baju ini bagus atau tidak, ya, kasih rating berapa dan seterusnya. It also can be data that can be used for analysis ya, using machine learning ya. Konsepnya machine learning tadi seperti itu. Oke, dan this is the publication that yang sudah saya buat gitu ya. I've published with Pak Arif and then Pak Arta, Pak Herlambang, and friends from Queen Mary University of London. We are collaborate, make publication together to make data augmentation. What is the problem in this identification? Tadi tujuannya adalah saya membuat data set, kemudian saya training ya, sehingga nanti ketika I have new image, new leaf image, then will be identified what is the best attack that mango leaf ya. But we lack of data ya, datanya sangat sedikit because it's very difficult to take the case dan kasusnya itu jarang terjadi. The expert collect the data from many years ago ya, jadi sudah lama sekali, sudah bertahun-tahun. Then maybe in this time some of the past is not appear, so it's difficult for us to add some images. So we have a problem when the data is only a little few, cuman sedikit gitu ya, dan the accuracy will be not high ya. Jadi akurasinya tidak akan bagus kalau kita punya datanya yang di training itu hanya sedikit. That's the problem. So how to generate the data? Then we propose the data augmentation. Kami membuat data augmentasi. Ini yang data aslinya. This is the original image. Then we will rotate in 3 dimension and then adding some blur, contrast, noise, and etc. So that every one image will produce another 150 images. Ya, setiap satu gambar kami lakukan augmentasi menjadi 150. Then we will have many new images, and then we train using our model ya, sehingga modelnya itu punya akurasi yang lebih bagus ya. This is one of our publication. This one is a security of facial biometric authentication that I show you. Bagaimana kita bisa mengidentifikasi ini wajahnya siapa ya, kemudian dia masuk suatu shift atau tidak gitu ya. It's publikasinya yang ini tadi masuk Q1, ini juga masuk Q1 ya. Mahasiswa pasca Amikom, mahasiswa S2 Amikom publish this paper and accepted in Q1 journal. Okay, and for another problem ya, masalah-masalah serupa actually there are many case in the field ya. Kalau kita datang ke lapangan ada banyak kasus yang bisa menggunakan cara yang sama ya. This is for vehicle classification and counting. When I met some friends in government in dinas perhubungan ya, then they have problem because they have camera in the traffic light ya, mereka menyediakan kamera di tempat lampu merah itu, but actually it's only for monitoring, monitored by people ya. Jadi they have a staff that look at that video and then identify what happened and etc. But it's need many people ya, banyak jam and ineffective because the data is not recorded ya. Jadi ya cuma ngamatin doang kalau ada masalah dan melaporkan, but it's not recorded ya. Berapa banyak kendaraan yang lewat dan sebagainya itu tidak terhitung. Dan the governor of Jogja want to identify actually how many vehicle ya yang lewat, berapa banyak kendaraan yang lewat di suatu perempatan, berapa banyak truknya, how many bus, how many motorcycle ya, how many beca and etc., how many andong and etc. ya. Nah, this is the problem. So we can use kamera ya yang dipasang untuk monitor tadi ya, the monitoring camera, and then we add some algorithm ya to identify what is the vehicle ya, apa yang sedang lewat dengan cara yang sama tadi. We use images and then we train using CNN, and then we have model, and when we have a new image from video actually ya, then we will classify and the classification then become a statistic ya. Ini bisa muncul statistiknya berapa banyak kendaraan yang lewat di suatu titik persimpangan itu dalam satu hari and etc. ya. This is the prototype ya. Ini sekarang sudah dipakai begitu ya. Ini adalah prototipenya ketika melakukan proses identifikasi, ini bus, ini car, then there is counting, and then from the interface it will be the data will be sent to server ya. Jadi data-data perhitungan ini tadi dihitung dalam 1 detik atau mungkin 1 menit atau satuan waktu tertentu, then the result will be sent to the server to be calculate become a statistic ya. This is the way to make a dataset. Jadi untuk membuat datasetnya kita anotasi, ini gambarnya dikotai, kemudian tulis oh motor, ini mobil, ini bus dan sebagainya ya, untuk training tadi ya. This is the concept of machine learning tadi ya, machine learning. Not only for image, video, but also for text ya. We also can make analysis for text ya. Misalnya ini ada kalimat untuk apa sih, feedback, masukan, saran ya. Kalau teman-teman punya aplikasi atau mungkin punya layanan, then someone will give some feedback, and then we want to know which is the feedback is good or not gitu ya. Kalimatnya panjang, ini sebenarnya senang nggak sih gitu kan. If there are many feedback, then we have no staff that identify all of the comment, then we just identify is it good or not, goodnya itu di mana ya, what part of that kalimat itu, that sentence that show that it's good respond or bad respond ya. Then the calculation will be show as a statistic, atau mungkin akan dijadikan justru apa ya, kayak bahan untuk membuat decision support system ya, bahan untuk membuat keputusan ya. Itu juga tadi dipublikasikan di Q3 Journal oleh mahasiswa Amikom, mahasiswa MTI ya, bimbingan saya. Oke, dan the other application of artificial intelligence ya, tadi contohnya tadi kan yang saya bahas itu adalah machine learning ya. Kemudian yang berikutnya, contoh yang berikutnya itu ada yang namanya expert system ya, sistem pakat. I have 2 books, I wrote 2 books about the expert system ya. Ini buku jadul sudah sorry okay. Sorry, Pak Arif, I mute him. Yeah. Yes, this is the concept of artificial intelligence yang jenisnya adalah expert system ya. Kalau tadi kita bicara machine learning bahwa sistem itu akan belajar, we give data and then it will be trained and then become a model ya, lalu akan digunakan untuk identify something new ya. Dan what is expert system ya? Kalau gampangannya, kalau saya bahasa awamnya expert system itu adalah cara membuat sistem untuk bisa bekerja seperti pakar. We want computer to become like expert ya. Kita akan membuat sistemnya itu bisa membuat orang awam, ordinary people gitu ya, untuk become an expert to solve something ya. For example, the expert in diagnosis will be a doctor, and then we are not a doctor, we are not learn about health, but we want to know something. Maybe my son, my children have difficulty and it's not a proper time or proper place. For example, maybe I'm in a remote place and then it's in the night, for example, it's difficult for me to ask for a doctor to help me, so that I want to give pertolongan pertama, the first help for my children. So I want to know, I want to identify what happened with my children, yeah, what should I do with that, yeah. So I can make an expert system to help ordinary people to become expert. And there are two components in the expert system. The first one is knowledge base, and then the second one is inference engine. What is knowledge base? Ya, ini adalah how to extract the knowledge from the expert. For example, this is an expert, and then how a computer can process the data, the fact, and compare with the rule. So the rule itself has to be externalized, ya, harus dieksternalisasi, become a knowledge base. And then inference engines, the task of the inference engines is ambil data, taking the data from the fact from the user, and then comparing with the knowledge in the system, and then become an advice or conclusion or else ya. Jadi akan bisa menjadi sebuah keputusan, sebuah kesimpulan dan sebagainya, saran begitu ya, to do something after we know the condition, the conclusion ya. Okay, and the way to make knowledge-based representation, there are many ways ya. Salah satunya adalah dengan menggunakan logika. If I have this tree ya, ini adalah silsilah ya, tree about family tree ya. Ini this is the grandfather have of maybe this is the second layer ya, the son of Pak Slamet, for example. There are Amin and Anang. Then Amin have two children, Anang has two children, and extra, then it will be ditunjukkan, dibuat dalam bentuk logika seperti ini ya. This is one of the example how to externalize the knowledge about family tree. And then we also can make rule base ya. Rule base itu menggunakan jika maka. Sorry, Simon is still in bahasa. If there is a wound, then give betadine, for example ya. Kalau terjadi luka, berikan betadine ya. If you have no money, then take from the saving, for example ya. If you got cough ya, and then bersin-bersin itu apa ya, and then kita bisa menyimpulkan itu jadi influenza ya, and etc. This is one of the way to represent the knowledge. The other way we can use semantic network ya. Ada node, there is a node, and then the link between node ya, that represent the relation between node and others. And the problem is when we want to externalize the knowledge from the expert, we know that the expert know many things ya. Doctor will have many patients in a day, and every problem they have, they can solve it. Yeah, they can solve it. But if we ask them about the knowledge, how to identify the disease of the patient, for example, maybe it's hard for them to tell us, not because of they are pelit gitu ya, don't want to share their knowledge, but they will confuse how to explain the knowledge, how to externalize the knowledge. They know they can do that, but they cannot explain. That's the problem. So we can use another way how to use not manually making the rule based or semantic network, but by taking from the data. For example, we can medical record. You take medical record. For example, this one I have data, about is he smoking, anorexia or not, cough or not, there's a problem in breathing or not. Then what is the diagnosis? We have this data, and this is certainty factor. How many our belief, or certainty about the fact, about the data. And then from this data, because of course this data is available, because all of the stuff, doctor and paramedics, they will record all of the diagnosis, and the result in the medical record. So we can take the medical record and then doing something using an algorithm to automatically making a decision tree. And from this decision tree, we can extract into rule based automatically. Then after we get a rule based, then we can apply to our system, sehingga nanti kalau ada kondisi di mana, for example, we know that there is a problem here, then the system will identify what is the conclusion, apa diagnosisnya, by following the model in decision tree, and the data not only from the data set that's in a table, for example. Sometimes we got data in unstructured form, in unstructured form like this. Maybe we have some news, asap dari kebakaran hutan merusak lapisan ozon, for example, then cegah kebakaran hutan dan sebagainya. This is the example data, unstructured data in the field that we got, and then what should we do to become a knowledge, itu adalah satu tantangan. And Simon is the expert here. Then he will explain how to extract the knowledge from the text, and maybe he will demonstrate the results. Okay, and for expert system, artificial intelligence, I provide a YouTube channel, some videos there. You can go to Bitly, YouTube Kosrini, and then there is a playlist artificial intelligence, or you can use this link. There are some videos about what is the difference between decision support system and system pakar, and then what is the relation between system pakar, machine learning, and then jaringan saraf tiruan, how to apa cara kerjanya, mesin inferensi, bagaimana cara menangani ketidakpastian, and etc. And there are some also video of presentation from me and my students about artificial intelligence as well. Okay, it's about expert system. Mbak Rona, if the time is limited, just tell me, because yes, it's difficult to stop, the other part of artificial intelligence is computer vision. What is computer vision? An interdisciplinary scientific field that deals with how computers can gain high-level understanding for digital image or video. From the perspective of engineering, it's like understanding automatically tasks. When we have this picture, then we can identify what is that. Ini apa sih, gambar apa sih sebenarnya? Oh, gambar kecelakaan kereta. We can identify. Human can identify because we have intelligence to make the identification of that. But how computer work? Bagaimana gambar ini bisa dikenali oleh komputer? Actually, this picture is only terdiri dari matriks angka, There are kalau putih ini 0, kalau misalnya hitam itu ini 9, tergantung levelnya, bagaimana berapa bit gambarnya. Kalau misalnya 1 bit itu berarti akan ada 01, only monochrome, and only 0 and 1. And then if we have 8 bit, then it will be 0 until 2 pangkat n minus 1, 2 pangkat 8 minus 1, become from 0 until 255. Nilai-nilainya, angka-angkanya antara 0 sampai 25 untuk menunjukkan gradasi dari grayscale-nya, ya. Okay, then this is the task of computer vision. Yeah, I took from Wikipedia. Yes, from this image we can know that this is elephant standing. Ya, kita bisa melihat bahwa ini ada gajah yang berdiri. Then we can identify a red shirt on a man. Yeah, and then man wearing a black shirt. And then a large green trees, for example, roof of a building, etc. Ya, dari gambar ini kita bisa mengidentifikasi banyak. But for the computer vision, of course, we can also limit apa yang harus diidentifikasi based on the goal of the computer vision. For example, if we want to make a robot for identify the fire, then we will give the robot the knowledge about this is fire, this is not fire, this is fire, this is not fire. The most important task is to identify which is fire or not. If it's fire, then what action that should be done by the robot and etc. This is the example of the computer vision. Then the other task of artificial intelligence is about natural language processing or NLP. Yeah, is an area of computer science and artificial intelligence concerned with the interaction between computer and human language. Ya, bagaimana interaksi antara komputer dengan manusia, bahasa manusia. Ya, how can computer understand our language? Ya. Kalau saya perintahkan komputer tolong dong carikan artikel tentang artificial intelligence ya. I ask computer to looking for the article about artificial intelligence, and he understand. Computer understand what I mean, and then give the result. This is one of the example of the NLP. The challenge in natural language processing is frequently involved, speech recognition, natural language processing, natural language generation, natural language understanding. Bagaimana kita paham kalau orang ngomong, komputer itu paham maksudnya apa. Then after we got the understanding of the language by user, and then the next challenge is how to give feedback, the right feedback. Bagaimana bisa memberikan balasan yang benar, memberikan respon yang benar. Can be a sentence, can be a voice, or maybe action. If it become a sentence or voice, then we can use natural language generation, mengenerate sebuah kalimat bahasa based on the natural language understanding. Okay, this is our research about natural language processing. Ya, kami bekerja sama. Ya, we are cooperate with University in Arab. Ya, ini Pak Arif yang menjadi koordinator. Kami bekerja sama dengan perguruan tinggi di Arab untuk membuat beberapa publikasi terkait dengan pengelolaan bahasa. Ya, this is when we are discussing about one of our publication, and now this publication, the paper has been published in Q2 journal, about Arabic language opening mining based on LSTM, and we also got some funding from ministry dari pemerintah Indonesia, from Dikti, ini beberapa dosen pasca, because I'm in graduate program, Prof. Emma, kemudian ada Pak Arif, Bu Rini, we doing some research about artificial intelligence, ada yang tentang NLP, ada yang tentang computer vision, and etc. Tahun ini juga begitu, dan this is the way for us in my university study program, we bring students to the field, kami bawa mahasiswa ini ke lapangan, for example, this is when I have case to counting and classify the vehicle, and then I bring students in ATCS, tempat kontrol dari CCTV-nya itu, then we meet the stakeholder there, and then we propose some solution for that problem, I bring the problem to the class, ya, saya bawa ini ke dalam kelas, ya. Biasanya I will give the material in a class before mid semester, and then after semester will be a project. The project will taken from the field, ya, including this is the decision support system and data science as well. I do the same dengan cara pendekatan yang sama, ya. Then student will present their finding, and then we also give feedback to the stakeholder and also publish the result. Yeah, okay. And by using this, yeah, we also invite some professors from abroad. This is Prof. Ibu from Queen Mary University of London. We have a program in world class professor from Dikti, and then we invite them and giving us some pendampingan to make a good publication, yeah, and the result the students of Amikom can publish very good, yeah. We also make event to publish their paper, yeah. We have ISO SCT, and actually this is already open now, ya. Sekarang ini sedang penerimaan paper. Kalau teman-teman juga mau publikasi nanti bisa di sini. We have ISO SCT. The submission will until 16 June, ya, 15 June, 15 Juni. So we still have about 17 days if you want to publish in this publication in this conference. And this is the conference. Last year conference, we invite some professors, including our friends from Queen Mary University of London as well. Krishna also give some talk here, and this is a professor from Japan, from Malaysia, and etc. This is our way to provide to make students can publish their paper well, yeah. And the result, there are many publications from our students, and also we motivate them to follow some competition about artificial intelligence. We support them, Amikom support them, yeah. And then some of the students got penghargaan, ya, appreciation, become winner in some competition. Yeah, I will skip the video. Actually, there are some videos, interesting video there, but I know the time is very limited, so I just skip it. This one as well. The students provide glass and shoes, yeah, for blind people, yeah, and it got some award, yeah, from international. And students also yes, doing some publication as well, as I mentioned, and it bring them get opportunity to student exchange with many university outside, including in Spain. Yeah, they got scholarship in Spain because Amikom has cooperation with them. Okay, yes, and the last one, this is we also invite students to bergabung, join with our research. For example, this one is Pak Mimboro, ya. Pak Mimboro is students in Magister of Informatics, and he make some an application to support the Silvanus project, and he got funding from the project, ya. Untuk tesisnya dia dapat beasiswa, dapat pembiayaan dari project Silvanus yang akan dikerjakan sampai 2025. And we provide some untuk other student, ya, student yang lain yang ingin join, we will give the same. And this is the experience because we invite him to follow us to the field, ya. Ini ketika kita ke Kalimantan, he also went with us ya. Ini ketika kita naik klotok ya, klotok setelah masuk hutan, then we go to the beach ya, masuk ke laut ya. Kemudian ini aslinya luar biasa kacau ya, karena pada takut pada jerit-jerit gitu ya untuk bisa mendapatkan gambar ini. Yes, want to be like them? Ya, you can join if you are from high school ya, yang dari teman-teman SMA bisa join, nanti setelah lulus bisa join di program studi kita di S1, D3 kita punya 17 program studi, and then for you yang sekarang sudah kuliah S1 ya, kalau mau join kita di S2 kita ada begitu ya, bidangnya informatika, and yang sudah lulus S2 want to join in the postgraduate, we also will have coming soon ya, coming soon ini segera dibuka insya Allah. The proposal has been submitted. Hopefully this year we got the permission to open doctoral of informatics. Okay, that's all from me, Mbak Rona. Matur nuwun, terima kasih, thank you, grazie.
Cik, yeah. Thank you very much for Professor Kusrini. So we have a session for Q&A. To all of you, if you have a question, you can raise your hand or maybe you can chat in the Zoom and I will help you to ask to Prof. Kusrini. But our time is so limited. Maybe just two people who will luckily can ask question for Prof. Kusrini. So AI is really helpful for anyone, yeah, right, Prof. Kusrini, for mengambil kebijakan untuk peristiwa dan lain sebagainya, bisa dijadikan data ya, Prof ya, dan di-identify untuk membantu pengambilan keputusan ya. Banyak di S2 banyak yang mengambil tesis about AI, Prof.
Ya. Betul sekali. Ya. Many students that doing research about AI because yes, the basic knowledge we give is about AI, data science, and etc. So many students doing this research.
Okay, so everyone in here yang mungkin belum ada judul buat tesis ya, siapa tahu terinspirasi juga untuk mengambil about AI ya. So everyone, if you wanna ask, maybe all of you in here udah clearly dapat ini nih materi dari Prof. Kusrini.
Kayaknya jualan jamunya udah cukup nih Mbak. Ya, I think it's easy to understand. Hopefully tidak bertanya itu ada dua kemungkinan ya. Clear banget, paham banget ya, totally understand or totally don't understand. So but I think it's okay if you want to discuss with me. You can email me in kusrini@amikom.ac.id. Then we can discuss much about it. And for today, I think the time is for Simon because Simon will show much about the implementation of the artificial intelligence.
Okay, thank you so much, Prof. Kusrini. So maybe if you want to ask to Prof. Kusrini, maybe later, you can DM or chat or email for Prof. Kusrini. And next is the session for Simon, but we have another moderator in here, my friend, my bestie. Hello, Kak Gardias.
Hi.
Hi.
Can you hear my voice?
Yes, I hear you clearly.
Okay.
How are you? Hi, Kak. How are you?
Yes, I'm good.
Are you in home, your house?
Yep.
So it's time for you. So give applause to Kak Gardias Bidari Adninda.
Okay. Thank you very much, Mbak Rona. So I will start this session. Okay. So good afternoon, ladies and gentlemen, and I believe it will be still in the morning in Italy. So I'm Gardias Bidari Adinda, and I will be your moderator today for this session. And previously, we already hear the previous session, which is very interesting. And now we still have another special session with a special guest, of course, and that's why we will have a special guest from Italy. And without further ado, because we only have a limited time, so I will read some of his CV first. So we have a special guest. He is Simon Martin Marotta, and please forgive me if I said the wrong um, pronunciation of your name. So he is has so many work experience. He worked as a knowledge engineer, experting in AI or AI in Naples, which works on development of semantic rules that provides the best result in order to meet customer expectations, and identification of logical patterns underlying the language, improvement of the basic technology from linguistic point of view, and so on and so forth. That I believe he has so many experience and his work. And previously, he finished his master degree in technical translation in 2020, and he will study in Università degli Studi in Naples, L'Orientale Naples. I don't know how to read that university. Maybe after that you can say it in a correct way. So without further ado, please welcome Simon Martin Marotta. Hello. Hi, Simon.
Can you hear me?
Yes.
Thank you. Sorry, my headphones are a bit funny. Okay, thank you Amikom for having me. I will plug the mouse back in and share my screen.
Okay.
Share. Can you see the screen?
Yes.
So, good afternoon, everyone. My name is Simone. Thank you for the presentation. I live in Italy, and I've been a knowledge engineer at Expert AI for more than a year now. Now, for most of my life, I've studied languages, mainly because I used to hate math when I was back in school. And so, as you were saying, I got my master's degree recently in translations. However, I was also a computer geek. So this double personality of mine eventually led me to merge the world of humanities with the world of the IT, information technology. Now, I don't know what all of you are studying, but I wanted to point this out just to encourage those of you that may be less expert in math like me, and make it clear that you don't need to excel in statistics or know in depth all the formulas to get good results with machine learning. It's really not needed, as you will see. But so today I will be sharing with you the experience I collected so far in my role in building machine learning models and using them to make classifications on textual data. The session is structured in two main areas. The first is a theoretical overview in which I'll try to keep to a minimum, but it's important to really understand what we're going to do later. And the other area is a code demonstration where we will get our hands dirty and go from start to end through the workflow of creating, training, and tuning a machine learning model with textual data. Finally, there will be, of course, room for your question and answers that you can even type in chat if you want to during the course of the session. The goal of the session is to give you the basic tools to create your own models and use them to make predictions, be it in a website, a web app, a mobile application, or anywhere else that you want. At the end of the session, you will have a link to the code that we will see on GitHub so that you can keep on tinkering with it. And I really suggest that you study it, change it, because it's one of the best ways to learn in my experience. So today we will cover the following steps: loading a dataset into memory, extracting features from plain text, training a classifier, building a pipeline. We will see what it is. It's really easy. Evaluating the performance of the model we train on the test set, proving our model with hyperparameters tuning, and exporting the model for production. There are a couple of Python libraries that are commonly used for the task of machine learning, such as Scikit-Learn, TensorFlow, or PyTorch. For our approach today, we're going to use a Scikit-Learn library, since it's probably the most beginner-friendly and easy to use. I don't know if any of you has already experience with it, but we will have a look at it a bit in depth later. Scikit-Learn, before I continue, Python is the programming language that is most used for machine learning. The Scikit-Learn library offers a number of different models or algorithms that can be trained by feeding them a variable x, which is usually consists of a table of numeric values, where each row of the table consists of a data point, and a variable y, which is the goal variable that Kusrini was showing earlier, which contains the correct values for each data point. To put this into a real world perspective, into a real world example, imagine you are cleaning your inbox, your email inbox, and you need to figure out, okay, which email is spam, which email is not spam, which one do I need to delete, and which not. In this case, your emails are going to be your X variable, and the label spam or not spam is going to be your Y variable. This picture that you see on the screen does a good job of summarizing the life cycle of the machine learning process. You start on the top left with a collection of data that can be of any kind, such as text, images, or audio. And you apply some kind of transformation to represent that data using numbers. You feed those numbers to a machine learning algorithms so that the algorithm can learn to classify new data based on the experience gained from the training process. And finally, you use the trained algorithms or predictive model in this case to make predictions of new data that has never been seen before by the model. As we just said, usually the X variable is represented by a table of numeric values. But in the case of text, in the case, for example, of emails, these are just text data. So how can mathematical models that knows nothing about language, about human language, correctly classify a piece of textual data such as an email? Well, there are some natural language processing techniques that will help us in this. And most notably, we will have a look at the bag of words representation and the term frequency by inverse document frequency representations. Bag of words representation is very easy. It consists basically in counting the number of occurrences of all the words from the document inside of a single document. While the term frequency by inverse document frequency, it's a bit more harder to understand, but it consists in measuring the originality of each word of a document by comparing the occurrences in a document with the times the words appear in all the other documents. So think about a preposition, a word that is mainly grammatical. This is likely to appear in many texts from your corpus, from your collection of text. So it will have a lesser importance. While a word that appears only in some of the text out of all the corpus will be mainly more characteristics for that a set of text and maybe be more useful in classifying that text. These two techniques can transform raw text data into numerical representation based on the word that the text contains. And this numerical representation can then be fed to a machine learning model. Again, this transformation is made easy by the Scikit-Learn library, as we will see. This example, this image shows a nice example of bag of words representations where we have two documents in our corpus, and we take all the words, all the unique words from both documents, excluding stop words. And for each document, we count the number of times each word appears in it. So document 1 will have this selection of values, and document 2 will have this other selection of values. Once we have this numerical representation, we can train one of the models offered by Scikit-Learn. And this is very easily done by calling a function called fit and feeding it our numerical feature as the x variable and our labels as the y variable. Now, there are of course many different machine learning algorithms, and the choice is mostly a trial and error process and also a bit of experience. However, there are a couple of models that are suggested for the task for language-related tasks, and we'll have a look at this algorithm in particular. Once the model is trained, with our data, we want to know, of course, how good our model is. So we will also check metrics such as precision, recall, F1, and accuracy. But we are greedy, right? We don't want to stop here, and we want better results. So we will also try to improve our model, the performance of the model, by automatically tuning the hyperparameters with a tool called grid search. Now, normally we would train a model with a set of hyperparameters, then check the results, then change the hyperparameters, train again, and check again the results. This is very time consuming, but with this tool called grid search, we can say, hey, you know what, try this set of values for these hyperparameters and come back to me with the best values for each of the hyperparameters. And this is done automatically, and it saves a lot of time. Finally, after trying to improve our models, we will package our model in a single file that can be exported and used in any other settings and applications. Now, if all of that sounds good, we can check if there are any questions from you for now, and eventually delve into the code to really see how this is done in reality. Any question? Let's see in chat. Nothing in chat.
Oke, teman-teman, mungkin ada pertanyaan terlebih dahulu. Kita diberi kesempatan untuk bertanya. Maybe you can raise your hand, or you can write it in the chat box. That will be okay. Before we move on to the
at the end.
explanation.
Okay, I hope this is readable for you. If it's not, I can
I'm sorry, Simon. I think I can hear your voice. Do you say something?
What about now?
Yes, it's clear now.
Sorry about that. Okay, we can look at how this is done in reality. We start from by loading a data set. We can import a data set from offered by our library. And this contains some text that is classified with different categories, with 20 categories. In our case, for the sake of time, we load just these 4 categories, which is atheism, Christianity, computer graphics, and medicine. And we can run and load it into this variable. And this was okay. Sorry, and we can print one of the text from this data set. As we can see, this is an email, and here is the label of the emails. It is about computer graphics. We can our data set contains these labels, and this variable target contains all the goal variables that are associated with every text in the dataset. So these are numerical, but these are associated with these labels. For example, this the first one corresponds to the text that we saw here, and is number 1. Now, if we count in our target names, this is 0 and 1. 1 is computer graphics, and of course, this text is computer graphics. So this is correctly labeled here. You can check how many texts are in our data. It's 2,200 texts. And we can move on with transforming these texts into numerical representations that can be fed to our model. Do so, we start with the bag of words representations that we saw before. And it can be done using this count vectorizer tool that is made available for us by the Scikit-Learn library. You can think of this count vector as a tool from our toolkit, right? Like a screwdriver, like a tool that we can use to manipulate the text. And we indeed do manipulate the text by using it here and feeding it our texts that are in this data variable. So once we do this, we will end up with this string counts variable that we can check out. And we will see that the shape of this variable is of 20,000 text, 2,000 rows, which is the length of all the text, and there are 35,000 columns. These are all the words that are present in our corpus, all the unique words from all the 2,000 texts. Once we have run this vectorizer on our data, it will also store some kind of information. It will have a vocabulary which contains all the words, and we can have a look inside of this vocabulary. And these are all the unique words that are from our text, all the texts. As you can see, there are a lot, 35,000, and we can see this is best shown here. We in this case we are seeing the words from the first text, so from this email, with their bag of words representation. For example, from appears just one times in all the text. City, there is a 4, so it appears 4 times in the text. And we can check this easily. If we go here, look for city, 1, 4. So this text, all the text has been represented with the bag of words representation. We can, okay, this we can skip, and from this is all fine. Occurrence is a good start, but there is an issue. What if a document is longer than another? They can have all different lengths, and a longer document will have on average higher count values than shorter documents, even though they might be about the same topic, right? So to avoid these discrepancies, we can divide the number of occurrences of word in a document by the total number of that document. And this is exactly what a term frequency is. So we can again transform these bag of word representations by another layer of transformations, which is offered with this other tool that is called TF-IDF transformer. Now, for now, we will see only the term frequency, or only the TF part, by excluding the inverse document frequency. We can apply these transformations just like we did before with bag of words, and we can see visually how the representations of the words from our original email changed. So for city that earlier was 4, now has a value of 0.3, which if you see the average of the other words that appear one time, it's a lot higher, but it's more balanced in a way. So all the words that appear one times are 0.07, disappear 2 times, so it's 0.15. City appears 4 times and it's 0.3. Okay? And we can apply another refinement on top of this to decrease the weights or what occur in many documents. And this is done by applying also the inverse document frequency part. And we will see that we can compare how the values change from using just the term frequency and using instead also the inverse document frequency. Let's take city again, for example. City was had a value of 0.3, so a relatively high value. Now with applying the inverse document frequency, the value is much lower, 0.04. And this is probably because city appears in the first email, but also appear in many other documents that are in our corpus. So it has a less informative value in trying to represent this text. So for another example can be the name of this guy that the email was sent to. It was higher in earlier, and here is lower. We can also check a case where the value went up. For example, the word images was just 0.07, and then it became 0.24. So it became more important in classifying a text for this corpus. Now that we have our transformation, our text in a numerical shape, we can load one of the models. This is called the multinomial naive Bayes, and we can call this fit function and give it our x variable. In this case, the TF IDF representation of our texts, and the y variables that are the target that we saw before. And just like that, we trained our model. And we can use this model to make a prediction. Now, of course, I want to say this was very quick because the data set is pretty small. But usually you have lots of data and it can take minutes or hours. But in our case, we can check these new documents. For example, God is love, OpenGL on the GPU is fast, or a new vaccination against COVID has been found. And what is important here is that new documents have to undergo the same exact transformations that the training documents have undergone. So we transform the new documents with a bag of words representation first, and then we transform that representation with a TF-IDF transformer. And now that we have this transformed representation for new documents, we can feed them to the predict function of our model. And with this function, we can store the predictions and we can print them. And in our case, God is love becomes classified as Christianity, topic about Christianity. OpenGL is classified as computer graphics, and a new vaccination has been classified as medicine. Now, we did these three passages, right? These three steps about transformation back of words, TF-IDF, and training the model. This can be summarized in just one single step by using this pipeline object, where we say, hey, first, whatever goes into this pipeline, first has to go through this count vectorizer, which is the bag of words transformer. Then has to go through the TF-IDF transformer, and then you can train this model with the result. So just like before, only just in one single step, we can say, hey, take this pipeline and fit our data. And this should be the, of course, the TF-IDF representations, because this is just the textual data. Okay, we don't have time for this now. We skip ahead for now. This, okay, text, see, let me check real quick. What's the problem? Yes. It's not defined. I forgot to run this, of course. And now it should work. I forgot to run a piece of code, nothing too much or a problem. Now we are going to evaluate the performance of the model by loading the test dataset. Here we load the test dataset from our...
Hello, Simon. I think your voice is getting slow again.
Hear me now. Okay, wait. Can you hear me now?
Yes.
Sorry about that.
It's okay.
We were looking at evaluating the performance of the model we just trained. So we load the test dataset, and to evaluate the performance, we have to make predictions on the test dataset. Okay, these predictions are stored here, and we can compare our predictions with the actual truth of the test dataset. And through this method, we can get our accuracy, which is 83%. So every out of 83%, 83% of times it is right. And we can have a look at the predictions and the real data and the real target values. Here is 2, and in the real data is 2, and 2. Now this has been predicted as 3 while it was 2. So every now and then it's wrong, but it's okay. But we can have a look at another model which is suggested for textual data. It's called the support vector machine. And again, we set up a pipeline like before, but here we use another classifier. And these parameters are what's called the hyperparameters. For example, alpha is an hyperparameters of the support vector machine. And these are mostly trial and error. Sometimes there's a bit of research to be done in the documentation, of course. But we can, again, fit these new algorithms, just like we did before, make predictions on the test set, and that gain the accuracy. And we come out this time with an accuracy of 91%. So a big improvement. And we can check out these more in-depth metrics that our library makes available for us. And we can see for this single classes how good our model did. So for atheism, there was this precision, for computer graphic, this precision, and so on and so forth. We can also print called the confusion matrix. This gives a graphical representations of the predictions our model made. So the actual the true predictions are the numbers that you see in this diagonal line throughout the square. And for example, the true label of alt-atheism has been predicted correctly 256 times by our predictions. And it's interesting to see here that the alt-atheism text has been predicted 36 times as Christianity, right? Because this 36 is relatively higher than all the other numbers in here. So the models is confused between atheism and Christianity because, of course, these are similar topics in some shapes. So it's nice to see this graphically represented. But we are now having a look at the grid search tool that I was talking about before. And this can be used to automatically tune the hyperparameters that we were looking at before. So we start by defining what we want to try, what values for each hyperparameters we want to try. So for the bag of words representation, we will try these different values for the range of n-grams. That is, instead of one word, instead of just one word, try both, try also pair of words. Or for the TF-IDF transformer, use the inverse document frequency or try without document frequency. And for the classifier, we will try for the alpha hyperparameters these three different values. And the way it works is try, okay, first I will try this value, and with this value, and see how it did. Then I'll try again this value with this value and with this value and see how it did. And I will try this value, this value, this value, and see how it did. And there should be 12 tries in total, because that's all the combinations of these parameters. And as you can see, it will take a bit of time. And the more combination you have to try, the more time it will take. In this case, it will take about a minute, and it will come out with the best combinations of hyperparameters. And after this, we can then use this improved model to make our predictions. So in this case, we can see the best score on the trained dataset has been 0.97%, so 97%. But we, of course, are only interested in the accuracy on the test dataset. So we will print here the original classifier accuracy was 0.91, if you can remember. And after the grid search, the accuracy has raised to 0.92, which may not seem much, but is an improvement, and it's done automatically, so we'll take it. And yeah, we can also ask what were the best hyperparameters that have been found, and these are all the best hyperparameters suggested by the grid search. We can also have a look inside at all the tries that it did. Every row consists of a try. And I can do this, and we can just see at the ranking. I can rank by the best score. And the best score here, the best try, was with these parameters, just like we saw before. Now, finally, we have this model that has been trained, has been improved with grid search. We want to do something with this model outside of this code. So we have to export it somehow. We will use Pickle, which is a tool for capturing object into binary files. And we will set all the data that we need to export. So we need a model which is at this variable, and we're going to use our target names too, and we save them to this file, save the steps.tcl. We will dump our data dictionary. We just have to run it, and we will find this file here in our files. We can also download it, but in our case, we will load it again. We will open this file that we just created, and into this classifier loaded variable, we will have data, the model that is saved in data. And we can also load the target names in the same manner. And we can make new predictions with the model, with the loaded model that we just created. So we, just like we saw before, this time we use the loaded model with the predict, and we feed him a sentence just to try. This is a sentence about computers, and we print the label, and just like that, our loaded model correctly predicted the topic of this sentence. And now, just like we did here, you can load it anywhere else you want in a website or anywhere else that you need this model to make predictions. Now, this is a reminder that I gave myself to share this code in chat. If I can get it. I want to share the link so you can have a look at the code for yourself with taking your time. Now we'll put it in chat to everyone. This is the link. And also, I prepared a little survey about this presentation, so you can give feedback to me personally for improving for next time. So it will take just about 2 minutes to compile, to fill in, and it will help me very much. Thank you, and take your time for it. Thanks everyone. If there are any questions from the audience, I'm open to them.
Okay, thank you very much, Simon. And wait a minute. Oke, so Simon minta tolong untuk rekan-rekan sekalian untuk mengisi form ya yang ada di jot form itu di kolom chat untuk diisi supaya bisa memberikan feedback ke Simon kembali gitu. Okay, so now let's move to the Q&A session. So I welcome to all of you to give a question or a comment or make a discussion with Simon. You can raise your hand or you can write it in the chat box. Okay, so Simon, I think I can't hear your voice. Not yet.
Now?
Yes. Okay.
Of information taken, so I get it.
It's okay.
It's a lot.
Well, we have one question, but she didn't want to say her name. She gave me a direct message, and I will read it to you.
Okay.
She wants to make a prediction on her dataset, especially to make prediction on unsupervised machine learning. Could you give her advices for the prediction? So she is asking for your advice to give a prediction.
So we usually we work with supervised machine learning. So when you have the labels, but from I have little experience with unsupervised, but I know that the technique of clustering can be used for unsupervised method. I already can research it more in depth. This is one way to collect all the data that has certain characteristic in one place and all data that has different characteristic in another place when you don't have labels for them.
Okay, so the answer is to find the deeper information about clustering. Okay. Okay, I hope it answer the question for one of our audience. And do you have another question, ladies and gentlemen? I think we have one who raised hand. No. Lutfi Nurul Huda, do you have any question?
First of all, I'm sorry I should off my cam, and
Okay.
here I am, Lutfi. I'm from Amikom University. I have maybe just a simple question for Mr. Simon. Here I have a case where I am doing a classification of spam, short message spam. Well, we define it into 3 levels. First level is for spam. Second is promo. And for the last is normal message. In the examples or in the previous research, the researchers is using knife bias. While my question is it possible if we use the same method with the different result in the accuracy? Maybe those. Thank you.
So you want to use different methods?
I want to use different, sorry, not different, the same method with different result. Is it possible?
What do you mean by results?
The result, what is? Sorry Mbak, Gardias, hasil maksudnya hasilnya gitu, hasil akurasinya gitu.
Okay, so the same method but different accuracy result.
So the accuracy you get it from comparing the prediction of your model with the correct labels. So the accuracy depends on your trained model. So I'm not sure I understand the question.
Pak Huda mungkin bisa diulangi lagi pertanyaannya, Pak?
Okay, maybe dibantu translate. Jadi saya ada kasus nih. Di penelitian sebelumnya tuh pakai knife bias dengan hasil akurasi 93% contohnya. Nah, saya akan pakai knife bias juga, tapi ingin membuktikan kalau knife bias itu lebih besar hasilnya. Apa itu mungkin?
Oh, okay. So, well, I will try my best to give a translation. So previously, he has done a research using net bias with, let's say, 80% of accuracy. And is it possible if he done another test with the same method, but the accuracy will be maybe higher or lower? Is that possible, Simon? Simon, I lose your voice.
Will be the one find is that there could be some kind of randomness introduced when you are pre-processing the data. So for example, there could be that every time that you run the whole process, the data that you get for training, for example, is processed in a different way. I would look at a variable called random state. Random state is a parameter that is used at least in Scikit-Learn, maybe even in other models, in other libraries, to always get the same randomness, the same operations. It's used for replicability of the experiment, basically. So you set random state to a number, an arbitrary number, and it will always be the same every time that you run it.
Okay.
I will have a look at this at first.
Okay, so the accuracy will always be the same if you run the same method.
Yes, yes.
Okay. Kayaknya begitu, Pak Huda.
Terima kasih, Mbak. And
Okay.
thank you for Mr. Simon.
Okay. And next we have another question. Maybe you can take a look at the chat box as well. Another question is from Cynthia Widodo. She was wondering, does NLP work in other language, Simon? So how to tokenize non-English language text in NLP? For example, in Indonesia, maybe a single accent can change a positive word into a negative one.
Well, I am sure that there are NLP techniques for many languages around there. They just have to be researched, but I'm sure that there are also for Indonesian language. I am unfortunately I just work with the Italian and English, so I don't know what could be the techniques. But I am most certain there they exist.
Okay, so it's possible. Okay. Mbak Cynthia Widodo, gimana? Is that enough or do you have another question?
No, Mbak, terima kasih. Thank you, Simon.
Okay.
Welcome.
Okay, terima kasih.
Zainal.
Yes,
Some question.
Zainal.
How about detection, automatic language detection? Okay. This method only works with one language. So for I never done automatic language detections, but I imagine it's a completely different workflow. I'm not sure I can help with that at this moment. But this works only for one language, what we saw today. Thank you.
Okay. Okay, Mas Zainal Abidin, do you have another question? Okay, thank you, Simon. Thank you, Mas Zainal. Okay, guys, do you have another question? We still have time. Anyone? So gimana, Mbak Rona? Can we close the session or is there still any other question?
Check. Okay. I think
Gimana,
the
Mbak?
time is enough.
Okay.
Because we already have overtime because
okay.
the participant is so semangat untuk
Yeah.
mengikuti acara kali ini, luar biasa ya.
Betul. Oke, saya tutup dulu ya Mbak, sebentar ya Mbak.
Okay.
Okay, so thank you very much for this session. Thank you for all of the audience. And also thank you very much for our special guest, Simon Martin Marotta. We hope that we can meet you again in the next future, online or even offline. Maybe you can go to Amikom in the next future. So thank you very much for this session. I believe that all of us give a good insight from you. Thank you. And I will give the session back to my bestie, Mbak Rona.
Okay, thank you, my bestie. Thank you, Kak Gardias. So I think today event is enough. Thank you so much for all the participant and also all the speaker. Thank you so much for Prof. Kusrini. Sarangnya, Prof. And also thank you so much for Simon Martin Marotta. Thank you, Simon. So maybe next time we will make the international webinar offline in Amikom. So we'll see. And stay tuned to Amikom Jogja. So thank you so much. Jangan lupa untuk isi presensi untuk mendapatkan sertifikat internasional ya. Mungkin Prof. Kusrini ada tambahan, Prof?
From my side is enough, Mbak Rona. Thank you very much, Simon. Maybe Pak Arif want to say something. He already opened cam.
Yes.
Yeah, okay.
Mr. Arif.
Yes, very nice to have you here, Simon and everyone. Terima kasih sekali sudah hadir di acara ini. We looking forward to your idea and your participation, and probably you can join Amikom in any case. Please come to do so if you have a research idea around machine learning, around computer vision or natural language processing. Please feel free to contact us. Probably we can join and make better work in the future. Thank you.
Okay, thank you so much, Dr. Arif. So I think that's all for today event for Seminar International. So this is not the last seminar. We will make another international seminar. So please stay tuned in our social media at Amikom Jogja or in international.amikomjogja. So thank you so much. See you again in the next event. Bye-bye.
Bye.
Recording stopped.
This city, everything about it. Food, culture, heritage, people, or how they complete each other. It's like the city is made for young people to learn and to be creative. In this mesmerizing city, I'm glad to be here.
For years, Amikom has tried to make a suitable place for their students to feel more enjoyment in their learning process. We believe that learning is not something that the students should do, but it should be something that they want to do. That's why we always support everything that relates to creative and fun learning activities. It is the essential idea of creativity, associating fun and learning all together.
One thing that I love about this university is that they allow us to experiment and try to make new things. It's okay to make mistakes and learn from them. So that's why they built so many facilities, labs, and also they have professional companies. We called it Professional Lab. We can experience what it is like to be in the real industry, what we need to be, the attitude, the skills, and everything that makes us valuable out there. It's like we are well prepared for something big.
When I first got here, I was completely full of worries. Not because of entering a new phase, but about the future. I wasn't sure of what I was supposed to do at that time. But it turns out that everybody does the same. And Amikom made it easier for me. Everybody supports each other. The lecturers, staffs, employees, and all of my friends, they are so lovely. We have sport activities and great facilities. The cafeteria is clean and neat. And the food, they are delicious. We are like coming into a big family.
If you are a person that is into creative things, I recommend you to come here to feel the atmosphere.
Enjoy the fun with the combination of nature, the city, and romance.
Join us and let this place reveal the best of you.
Come on, join Universitas Amikom Yogyakarta.